Great. Okay, I'm going to go ahead and turn my video off here. So welcome. If you guys have any of you familiar with Hycrete, we'd love to hear about your experience with us. If not, this will be an educational presentation for you all. So we will go ahead and get started. Andrew, if you can switch slides, please. Great. And like I mentioned, AIA accredited, so you'll get 1 credit point for that. And we are recording it. So if there's somebody else that does watch it afterwards, Christine, if you could let me know, then we can make sure that they get credit.
Okay.
Well. Great. Okay, next slide, please. All right, so these are the learning objectives that we're going to go over today. So we're going to go over how integral concrete technology can deliver sustainable benefits and protect your assets from moisture with increased durability, reduced risk, lower cost, and faster construction schedules. So I kind of like to start, I don't know what, I'd love to hear what your guys' preferred method of waterproofing is. But one of the things we have seen over the years, membranes can be wonderful and they work really well, assuming they've been installed correctly, there aren't weather issues, and they weren't damaged by potentially another trade. So unfortunately, we see a lot of membrane failures over the years, and for a long time, that has kind of been our only method of protection for a long time. But we want to go over the hydrophobic admixtures and the opportunities that those are going to provide you for better protection, both from waterproofing and corrosion protection. So we'll go through that throughout this presentation and the testing behind it. All right, so Andrew's going to talk about the general properties of concrete.
All right, good morning, everybody. Well, actually, at this point, it's good afternoon. So first, I'll talk a little bit about concrete. It's the world's most widely used building material. It's about over 6 billion cubic yards produced annually because it's inexpensive, readily available, has great compressive strength, and it's versatile, durable, and can be used in anything from your structural needs to your decorative needs. So concrete has 3 main ingredients. I'm sure you guys all know this. You have your aggregate, which is your stones, so either coarse or fine. You have your cement or cementitious replacement, and then you got the water. So importantly, in your average 5,000 PSI mix, you're going to look, there's 2 different kinds of water that we list here. You got your bound water, that's the water that goes into the reaction that helps basically create your concrete. And then you have your free water. That's the water basis extra that ready-mix companies usually add to go make sure that the concrete is actually flowable. That will eventually evaporate out, creating channels. Those channels called capillaries. It's important for you guys to remember as you go through this presentation. Something else you guys should think about as the presentation goes on is that water absorption is a critical problem in concrete. Concrete is basically a hard sponge. It absorbs 3 to 6% of its weight in water. So if you imagine it this way, averagely in a yard of concrete could absorb up to 25 gallons of water over a 30-minute period, basically letting it pass right through the concrete slab. So that's something basically most people want to avoid. You don't want to have that water coming in, bringing in all the deleterious material with it, like salts, or just having leaks in general, because that leads to corrosion, as you can see here on the right picture. So basically, there's 2 main transportation mechanisms for water to get through. Usually, you guys probably know about permeability. It's movement of water due to pressure, like hydrostatic pressure, basically pushing that water through the slab. There's also capillary absorption. Now, as that free water escapes through the concrete, it creates little channels. Those channels are going to call capillaries. Those capillaries can basically absorb all the water going through. Basically, imagine for a sec, if you have a tree, you want all that water to get from the roots all the way up to the top. Usually that's absorption, capillary absorption, basically free shoots the water all the way through. So basically using that same kind of dynamic, the water can be passed through the concrete. Now that's important because this works in areas that have pressure and areas that don't. Just like a sponge, you put it near a puddle of water, it's going to absorb whether there's pressure there or not. So next we're going to talk a little bit about concrete water-related challenges and consequences.
All right, so there's six things to think about when you're designing your concrete structure. Andrew already talked a little bit about capillary absorption, but we're going to go into more detail on that as well. Go ahead, you could switch to the next slide. Can you switch to the next slide, Andrew? There we go. Thank you. So as Andrew mentioned before, the free water that's going to leave the concrete, it's going to create the capillaries and the pores behind. So this network makes the concrete a hard sponge, which we mentioned before. So it's going to wick the water in through the capillary absorption. And as Andrew mentioned again, that it's that process of how a tree is going to get the water all the way up to the top of the branches and the leaves. It is using capillary absorption to do that. So capillary transportation, it's a very, very powerful method of absorption. So this graph shows that even by densifying the concrete, you're still going to have capillary absorption. So even though you can reduce the amount of free water needed in the high density concrete, you're still going to have about a 2 to 3% absorption from the untreated concrete. So the point we're really trying to drive home right here is that even in the denser, higher quality mixes, the capillary structure still is going to lead to capillary absorption of water and chlorides. So our second design issue is durability and maintenance. Typical membranes, as I mentioned before, if they're not properly installed or if they're damaged after being installed, this can lead to very expensive damage and repairs required. And then coatings and sealers will have to be reapplied about every 4 to 7 years. So then our third design issue, leaks in concrete. We all know concrete is going to crack at some point. So this picture is an example of a failed membrane where you're chasing the water. You're not sure where the water came in, probably in from the wall, if the wall wasn't protected. But again, you're chasing, becomes very expensive repairs and of course creates a lot of delays. So our fourth design issue is environmental considerations with concrete. This is a hot topic right now. I know everybody is trying to do their part to reduce the CO2 emissions. And that is definitely taken into account with your designs. So we know the kilns that produce the Portland cement, they require huge amounts of energy and the process itself releases CO2. The concrete in place is going to require other materials to help it meet its objectives. So if we can maximize the life of the concrete and maximize the amount that can be recycled at end of life and minimize the amount of supporting materials needed, then we've made green progress. And we all know that the most sustainable buildings are the ones that last. So our fifth design issue is aesthetics. So these two photos are examples of how the aesthetics of the concrete can be compromised, leading to staining, surface deterioration, and spalling. And our sixth design issue is compatibility and adhesion to the concrete. If the concrete's wet, of course, it's going to lead to failures of the coatings. Depending on the admixture used, this can affect the set time, the workability and finishings. This also can lead to construction delays. Next, Andrew is going to talk about concrete and integral technologies.
So first off, I'm going to ask the question, have any of you guys worked with a waterproofing admixture?
And you can feel free to write it in the chat if you'd like to. Also, we'd love to make note too, if you guys have questions throughout the presentation, please jump in, raise your hand, or just speak up. We'd love to answer your questions throughout the presentation as well as at the end of the presentation. But yeah, if any of you have worked with either with Hycrete or with another waterproofing admixture, please type that in the chat. We'd love to hear your responses.
All right, so we got no answers. I'm going to assume you guys haven't really worked with it that often, so I'm going to go through what it is from the beginning. So basically, it's a liquid-based product. It's dosed at a ready-mix plant, mixed into the concrete. So by the time basically gets to your job site, it's being poured, it's already mixed into the concrete itself, and it will provide a waterproof surface for that concrete so the water will not absorb. Now, there's two different technologies that could achieve water that are used in the waterproofing market. One is a densifying admixture. So some of the densifiers that are used in concrete are things like the cementitious replacement products. Think of it as fly ash, slag, or silica fume. Also, your treated silicates can be used as a densifier as well. That's in your crystal growth products. Last but not least, cement itself actually has densifying properties. So if you see a very tight water cement ratio, you also have some densification as well. The second category are hydrophobics. They're liquid based. So some of them are ammonia based and some of them water based. They're mixed in, as I said, liquid based, as a liquid based admixture. So when we talk about absorption, the American Concrete Institute, the Committee on Chemical Admixtures, has two different classifications. One is a permeability reduced in admixture with hydrostatic conditions. We're going to refer to it from here on out as a PRA. And permeability reduced in admixtures for non-hydrostatic conditions. That's a PRON. So we talked about before, so currently, the chapter defines those admixtures on the basis of capability of reducing permeability in all types. Historically, you only talked about permeability of under pressure, basically with a static applied head. Late assessment, they've determined that there's other methods of absorption besides just a Darcy flow, that all possible means of water transport should be evaluated. Basically, translate that, it's pretty easy in non-hydrostatic conditions for water still to go transport through the concrete. We talked about before, concrete's a hard sponge. So you're just looking for a static pressure head. It's not going to necessarily be the only mechanism where water is going to go through your concrete. So, like I said before, some of these different permeability reducers are things like fly ash, slag, silica fume. You guys probably heard of those before. They're industrial byproducts. Powdered, there's cementitious replacements. They're going to heal some of those hairline cracks, less than 0.4 millimeters. And then there's the crystal growths. Their powders are liquid. They're hydrophilic. So in order for the base for these crystal growths to react, water actually needs to come in contact with them. They will literally suck in the water. So you're bringing water into your concrete itself. And they will usually come with a product warranty. What does that mean? If this liquid or powder that we put into your concrete does not work, we will give you more liquid or powder. Honestly, it's not a surface applied coating, so it's not going to do much, but they'll give you free bags of it. Here's a picture of a hydrophilic crystal. You can see it here. The black spots still show that even as that crystal is forming, there's still voids there. There's still places in that crystal that basically the water can go through. It will slow the ingress of water. It will not eliminate it. Hydrophobics, they're polymer-based blocking agents. They basically block the water absorption, and they're hydrophobic. That means water repellent, not water absorbent. So you're looking at less than 1% water absorption. So it's liquid products that goes electronically. They're activated while concrete is still wet. You can heal those hairline cracks too, and it give sometimes a performance warranty with service from the manufacturer. Some of the products are also corrosion inhibiting. They're the only admixture that meets both the PRON and PRA criteria. So basically, what does that mean? Imagine it this way. Imagine you could put little rubber stoppers into your concrete, just like you would have a cork in a bottle of wine. Same idea with this with these polymer pore blocking agents. They're going to basically stop any of that water from getting into the concrete or stop it from migrating once it's in there. Here's a picture of concrete pour blown up. You can see here the green is the hydrophobic, the Blue is basically the pour, the concrete around it. As you can see, the hydrophobic completely surrounds any of those pores, so that water is not going to go anywhere if we got in. If there's a wet area of that concrete, it's not going to, the water is not going to migrate to any part of it. And that works at all depths of that concrete is mixed in integrally. So usually people, when they talk about doing dam proofing or waterproofing, they talk about a bunch of different products. Sometimes you have different ones, your low-end dam proofers, all the way up to your high-end non-stearate based HPBs or hydrophobic pore blockers. They cover the entire range from the dam proofing all the way up to the high end. It's one product fits all, so it makes your specifying life a little bit easier.
All right, so how do HPBs or hydrophobic pore blockers work in the concrete? They're at the highest level of performance, like Andrew just said. And so the admixture molecule, it chemically transforms the concrete, becoming a water insoluble polymer. And this transformation takes place immediately after it is dosed to the concrete. It reacts with the metallic ions in the cement and the rebar to form a protective layer over the rebar. This is the second method of protection. So we've got our waterproofing protection. Then we also have our corrosion protection. So we're going to show you an actual image of this polymer starting to take place and develop over the rebar. We'll show this in a slide a little bit further down. But the little yellow bits are meant to represent the polymers blocking the pores, and that's meant to represent a pore, not a crack. So the HPBs, they're going to keep the water out of the concrete and the corrosive agents away from the steel. So comparing the densifying admixtures, like the hydrophilic admixtures, to the hydrophobic admixtures. Densifiers like the crystal growth products, they require the absorption of the water to grow the crystals, which of course can then lead to freeze thaw issues and usually include a product only warranty. Whereas the hydrophobic admixtures, they're going to shut down the capillaries, thus repelling the water. So this is one of my favorite slides. So this really shows you the side-by-side comparison of the fully developed crystal growth product inside the concrete. This is inside of a capillary or a pore versus the hydrophobic pore blocker on the right, which is again filling up all of the potential voids with a less than 1% water absorption. Whereas with the crystal growth, yes, it is going to build more crystals over time. It's going to max out, and it can only grow to a certain point. So you're still going to have voids. It's going to slow the water down, but it can't stop the water. And it requires the water absorption to actually grow the crystals to function and do their job. So another way to think of it is a beaver's dam. You've got the sticks versus the mud. So the permeability reducers they're the sticks in the beaver's dam. They can only slow down the water. Where the hydrophobic admixtures, that's the mud. They're going to stop the water from even penetrating the dam at all. So when you're trying to determine the science between hydrophobic versus densifying admixtures, the biggest impact are the differences in the absorption. So these graphs are from an independent study using HPBs. The top two graphs show the difference in capillary absorption in the untreated concrete, crystal growth admixture, and Hycrete treated concrete. So as mentioned before, the crystal growth admixture requires the absorption of the water to grow the crystals, leading to an even higher rate of absorption over the control. So measuring the performance of densifying versus hydrophobic, only the hydrophobic is going to lower the absorption and enhance durability, provide corrosion protection, and the electronic quality control improves concrete consistency and performance. And as Andrew mentioned before, using an admixture that meets both the PRA and PRON will address both hydrostatic and non-hydrostatic conditions. And Hycrete is the only one on the market today that meets both. So then we've got our sustainability considerations for integrals. Does your integral contribute to LEED credits and sustainable building practices? Once a membrane or a coating is applied, the concrete can no longer be recycled once the life of the building is complete. We are the first building material certified cradle to cradle. Next, Andrew is going to talk about some applications and examples.
Thank you, Lindsay. One thing I wanted to point out, by the way, we did go over a little bit of a few graphs a slide or two ago. Every study we're showing you that is done on a graph was done by independent bodies. They were done either by DOTs, universities, or independent research labs. We have plenty of internal testing, but we never released that to our people like you guys, because quite frankly, we can make up any numbers we wanted. Everything we do has been third-party verified. So something you guys are probably thinking about at this point is, well, this technology is really interesting, but why do I need it and where do I need it? So the reason why you need it is to keep out that water. So you talk about the water coming from a whole bunch of different sources. You have your rainwater coming down, and your groundwater coming up. Basically, the source of that water could be either groundwater swells, rain, or your incidentals like your irrigation, snow, etc. Usually, to protect against it, you're going to need some complicated detailing. The concrete could be a little inconsistent on the pours. Multiple trades come in for that waterproofing, and if that system gets damaged, then there's cracks in the concrete, and you're all in trouble. So here's a quick slide of how easy it is to install a hydrophobic. You can see here, there's a hydrophobic concrete slab, hydrophilic water stop on the joints, and that's all it is. No complicated detailing. That's important because we're going to talk now about where you guys want to use it. There's a few different areas. We're going to have replacing those waterproof membranes. You can use it in any durable concrete requirements, replacing the coatings and sealers on parking garages, belted suspenders, and usable in architectural precast concrete. So we're going to start here at the beginning. When we're talking about replacing membranes, typical area of concern for waterproofing, you're looking at your foundations, your elevator pits, your podium decks, your plazas, your tunnels, and your water tanks. You're talking corrosion control also. You definitely want to think about parking garages and balconies as well. I see we got a question here. So here's the thing. You asked if we can be used with hydrophobic could be used with silicone fume for hardening and finishing. Probably yes. Silicone fume is one of those things we could definitely work with. Slag absolutely comes into play with the concrete. It's easily worked with it all the time. If you want to get the strength up for any reason to harden the concrete, it's easily usable. As I said before, what we talked about is compatibility of admixtures. And one of the great things about some of the hydrophobics is that they are actually compatible with many different kinds of admixtures. It's the kind of thing we consult with you guys as you're speccing, and we go through what we can and cannot do. But it's easily, most of that stuff, easily stuff we do every single day. So as I said before, here's some areas of basically you have to think about besides corrosion control in the balconies. Usually, when you talk about membrane, people just talk about it's a black line design method of detailing. Why? Here's a structure, and here's all the waterproofing. It's just a black line. They draw it out, it looks so simple. It never is. There's a bunch of different kinds of membranes people look at. It's either you have your liquid base, which are hot applied or cold applied. You have your sheet membranes, like your peel and stick, which are bituminous, your HDPEs, or your bentonite clay. And sometimes you get cementitious systems as well. Now, most of those systems are heavily reliant on labor. They require nearly perfect substrates and they're vulnerable to damage. 2/3 of the cost, in fact, is on installation. When usually you're paying for a membrane. And it's very easy if something goes wrong either during the installation, during the setup, or during or afterwards when they're doing other trades, that membrane gets damaged. And a damaged membrane is a useless membrane. And the first thing that happens when we see this all the time, we see basic problems on a waterproofing job, and it's a membrane problem. The first thing that will happen is that the installer will blame the product for being defective, and the product owner is going to immediately turn back to the installer and say, you damaged the membrane along the way. And there's a lot of finger pointing, and the owner's still stuck with a leaking structure. but it's also easy to mess something up. Why? Because remember we said that they say it's a easy black line. It's not. Here's a traditional traffic coding detail. You can see here, but it's on top of the concrete. There are, in fact, 4 additional layers that go on top of that concrete or the membrane. Each has to be applied separately. And for pipe penetration, even more. You have actually another 5 layers that go on there on top of the concrete. And that's for each, imagine that for that tieback, that's each penetration requires all those different layers and the time between them. So that's extremely important to think about because a lot of times it leads to construction delays. Membranes, for example, you need to wait to cure between levels, between layers. Basically, you can't apply the membrane too soon. Another layer on top of the old membrane has to cure first. Also, weather delays. If it's too cold, the membrane can't be applied. Too warm, the membrane can't be applied. If it's raining, the membrane can't be applied. You need to wait till the surface is completely dry for the membrane to be applied. Usually, if you have inclement weather, which let's be honest here in DC definitely happens, you can set back your construction schedule significantly, just wait for that membrane to come up. And while that's happening, your concrete is still basically susceptible to the elements.
So this is an example of a project that had significant weather delays and water issues. So this was one that actually is in the Seattle market. They had originally planned a membrane system. They were behind schedule by 30 days because of the weather issues and the water. They ended up calling us and using us, the hydrophobic admixture in place of the membrane. We were able to get the project back on schedule. So they were able to make up those 30 days. And then they had a more advanced structure that was better protected.
So as you can see here, there's a big difference between traditional solutions, which you guys usually are used to, like membranes and your integrals. Your traditional solutions, they're highly reliant on labor. Your integrals, not so much. Durability, your membrane's gonna last as long as it doesn't get damaged. Your integrals last forever because it's literally in the concrete itself, so it lasts as long as the concrete itself. Membranes could also, due to rubbing, could actually wear out over time. If there's any kind of freeze-thaw cycle, they can basically wear out in time because they keep damage. But once again, the integral's in the concrete itself. It never wears out. It lasts as long as the concrete does. And the footprint of construction is reliant, usually, your membrane is reliant on other trades, not so much the integrals. It's never going to affect your construction schedule. And the really easy to design, those complex solutions of membranes. And this is important. Usually, once again, membranes will give you a product-only solution, meaning if the membrane rips, they're going to give you more membrane. The integrals come with a performance warranty. What does it mean? If it leaks, the install basically will fix it. So for that to occur, you need a few different things. You need, besides to get that warranty, you need to have the technology in place. We talked about that. You need some service side of somebody basically looking over everything to make sure things designed right. Basically a partner for you guys as architects to work hand in hand designing a whole system of waterproofing. You need a team on the ground to actually make sure everything's being done up to code and to do the repairs if necessary. And then you actually need the warranty, basically something to basically protect at a number you could call. So when something goes wrong for the next 10 years, that will come out and fix it. This is going to go into a little bit more detail on all these systems approach.
Great, thanks, Andrew. Yeah, so like Andrew mentioned, you know, it first starts with the design, reviewing the design drawings, the architectural, structural, and the geotech. If there's below grade, our engineers review those to make recommendations on where using a hydrophobic admixture would provide the most value, and then also includes waterproofing details at no cost there as well. So then they're also going to review the concrete mix designs to review for low water to cement ratios for strong concrete with minimal cracking. Then there's also the pre-inspection services, there's the pre-con meetings, all involved at every step of the way so that we can ensure that everything is done correctly out in the field. So they're going to actually go out and review, make sure water stops have been properly put in and in the right locations. Also be out there when the concrete is being poured to ensure that the truck has actually in fact been dosed with the hydrophobic admixture. And then finally they're going to be there for the pours to review and make sure that all has been done correctly. And then again, there's with the warranty involved, coming back if there's any potential cracks or leaks after substantial completion. Our team will come in and seal those cracks and leaks. So integral waterproofing, we get this question coming up. How are you less expensive than the traditional membranes? And we're actually a lower first cost solution than the traditional membranes. Installed membranes cost range from about $1 per square foot for the lower end solutions, typically the peel and stick, all the way up to the teens for the high end HDPE approaches. On average, integral approaches are about 30% lower in cost. Now, if you're looking at a belt and suspender system with waterproof concrete without a warranty, and it's just product only approach, this is generally in the $1 to $1.50 per square foot range. And a lot of times what we've seen when we're seeing the comparison, they're like, well, no, you're more expensive. Well, they're taking into account the cost of the concrete and the cost of the admixture. But when they're looking at the membranes, they're only looking at the cost of the membrane and the installation cost. They're not calculating in also the cost of the concrete as well. So that sometimes is where we get the question coming up that we appear to be more expensive. However, it's not an apples to apple comparison because they're not including the cost of the concrete in with the membrane as well. So just something to keep in mind when you are pricing out or looking at different options. So when you're reviewing the risk comparisons of the membranes or the coatings to integral hydrophobic systems, the hydrophobic system is going to provide, like we mentioned, a 10-year performance-based warranty, not product, performance-based warranty. And all repairs are going to be done by the admixture company. With membranes and coatings, your risks are going to go up after the 10 years material only warranty. And of course, these risks are going to fall on the owner. So we really like to consider ourselves as someone who is going to shoulder that risk and take that off of your shoulders as the designers, and also take that off of the owner's shoulders as well. This is an example of a project in the Seattle market, the Bill and Melinda Gates Foundation, where they used on the 1.7 million gallon rainwater harvest tank. One of the things they really wanted to be able to do is over time, as sediment build up on the bottom, they wanted to be able to get in there and clean that sediment out without damaging the concrete if there was any coatings or sealers. And then also never having to reapply a coating or a sealer in these areas. So that was a good example of replacing coatings and sealers on this project.
So this is a project, actually, it's Columbia University, their school of nursing. So it was an existing building actually, and they wanted to expand it because Columbia basically took over a whole lot of more territory. So they expanded the building. You tie in for this one, you tie in a new structure to an existing structure. So the entire project also is certified LEED Silver on application. It's one of those projects has actually lasted at this point. We're up about at this point 8 years going on this one. We're still doing great and no complaints, and we're very proud of this one on our New York market as well.
Another example, this is the Google campus. This project is 3 mixed-use buildings. This is spanning across 3 city blocks. This has got high hydrostatic pressure because of its vicinity, how close it is to a lake nearby, Lake Union. This one is completely membrane free. This has been built, it's been done for about 3 years now. And to date, they have had no problems. It's very dry down there and they've had no issues and we have not been called out. This is a warranted project. We haven't been called out to do any repairs. So it's a successful project. This one, I really like this slide too, because I think it speaks for itself. The sustainability impacts of a membrane versus a hydrophobic admixture. The membrane, you've got all these different levels of just to even getting to the point of installation. Of course, you've got your delivery, your site storage, your construction waste, all the labor. And then, of course, at the end of life, it's non-recyclable. Where with the hydrophobic admixture, if you can pour concrete, you can waterproof and you can provide corrosion protection as well. And again, like we said, at end of life, the concrete can actually be recycled at end of life.
So this is actually one of my favorite studies. This is Thomas Jefferson School of Law over in San Diego. Basically, by using they needed to get some LEED credits for their building. So they used a integral instead of using a membrane. They were able to actually not only get those LEED credits that they wanted for membrane-free design, but they were also able to save money on the project and also get a comprehensively good waterproofing solution. Now, the reason why I'm really proud of this is, as you can guess, the board of Thomas Jefferson School of Law happens to be a board of lawyers. If something had gone wrong with that project and it had leaked in any way, that board full of lawyers would have sued us. Not only have they not, but we've been used again by all the parties involved on other projects too going forward. So next, we're going to talk a little bit about the durable concrete corrosion protection, and we'll lead that into replacing the coatings and sealers on your garages.
Okay, so these pictures are examples of durability issues in concrete decks. So you've got your lower levels, they're going to have issues with the cars bringing in salts. Of course, the garages are probably never pressure washed out. And then you've got your top deck, they're exposed to the precipitation, which can help wash away these salts. However, then you're going to have them be plowed. And if there's any coatings or sealers, those could be most likely damaged by improper plowing. Then you've got your corrosion in concrete, very expensive repairs. In the US alone, now these numbers are a little outdated. This is probably calculated about 5 years ago. So I'm sure with inflation, this has increased a fair amount with $22 billion annually in the US of repairs just for corrosion in concrete. So then also mentioned before the parking structures, you've got your top decks, the driving lanes and the turning areas. And those amount, the turning areas, those amount to about 35% of the square foot of the garage. So they're of course going to see the most wear and tear. And then you've also got shutdown and maintenance of that garage if we're reapplying the sealers. It's usually about a 1 week shutdown. So 2 traditional approaches include the traffic membranes and coatings and the penetrating sealers. So as I mentioned, you're going to have with the traffic deck coatings, those are about $1.50 per square foot to remove, another 25 cents for surface prep, plus it's a solvent base. So you've got a 1 week shutdown to install and repair. This is of course leading to costly downtime and lost revenue. And then this has to be done every 4 to 7 years.
So as you can guess, probably it's a little complicated system usually to put down all those layers for a coating system. Easily have problems, but once again, there's an easy solution. It's an integral system. So the benefits of using integral admixture technology, it shuts down the absorption, it protects the steel rebar. It's a one-time application. It'll last the life of the structure. It's a dual mechanism, so it's corrosion protection in addition to waterproofing. It's going to be significant upfront and life cycle costs and reduced maintenance and downtime and simplified detailing. So we said before, there's two different mechanisms of protection. You have the water reacting with that calcium in the concrete to make one level of resistance for absorption. And then you have a separate layer reacting with the iron on the rebar. So those two levels of protection are going to basically make sure that that rebar is not going to corrode and your structure is going to be safe. So here is basically what we like to do. We take a few tests. On the left, you're going to see a picture of basically take rebar, stick it in water. You see the water basically after a little bit of time start turning yellow, rebar's going to begin to rust. It's pretty common. On the right, you're going to see what happens. We talked about this earlier. When the Hycrete goes into effect, it's almost instantaneous, basically. We talked about before, you line it into the concrete. You can see that cloud is a polymerization. Remember we talked about the polymer forming on the rebar? That cloud is a polymerization beginning to happen. So it's basically that cloud will cover the entire rebar. All the areas of it will then be exposed and will completely cover the rebar itself. Now that's important because it protects that rebar will be protected separately in both cracked and uncracked concrete. And there's two kinds of concrete in this world. There's concrete that is cracked and concrete that's going to crack. So basically, your hydrophobics are able to protect against both. On the bottom here, we have a picture of basically rebar, and it was taken, they casted a cylinder with a straight rod, called a lollipop sample. And then after, this was, I believe, after 2 years, they split it open.
Yeah, 2 years. Yep.
You could see here on the left, you could already see the corrosion significantly affecting the bars. You can see literally the concrete itself is black. You can see the corrosion coming through. Even there's some signs of corrosion with the inhibitor as well. You can see the hydrophobic, there's no corrosion damage whatsoever.
Yeah, and then just a side note on that one, those were immersed in a saltwater solution so that you could see how it's going to penetrate into the concrete. This is an example of a parking structure where they opted to go with a hydrophobic admixture for their protection for both waterproofing and corrosion. They were able to, they independently calculated that they were saving about $2 million over the lifespan of this parking structure by not having to use coatings and sealers and reapply those over time, plus the lost revenue of the shutdown time.
So this is actually a project that was over in New York. It is a 500 parking space parking garage with one level above grade and the second half is exposed. Also, there's a level actually below grade as well. So it's a highly corrosive environment. Soils are high in chlorides. The top deck would receive a lot of de-icing salts, definitely did, and exposed to weather. Durable solution requiring minimal maintenance. Basically, the integral solution was used to save money instead of penetrating sealers. Maximum corrosion protection and protection throughout the concrete slab and reduce those maintenance costs. Basically, if you think of it this way, most of garages, and this is a problem, in order to keep the durability up, you got to do two things. Either A, you got to make sure that your protective coatings are holding, or some people go the easy route with these penetrating sealers. Now that sounds great. 4 to 7 years, you reapply. Some people may think it's an easy solution, but it's not, because we all know a lot of these garages, they get sold pretty quick and they get turned over. And the new owners never know the schedule of when those waterproofing can apply. So when you talk about the penetrating sealers, they're never going to keep an accurate schedule of when they're supposed to reapply it. And they're going to find out too late that damage is being done. And then they have to call for repairs. This is a study done by New Jersey DOT. This is actually called DOT's Route 130. They did a test comparing Hycrete versus their high-performing mix. This is what they use when they get a lot of snow in the northern parts of New Jersey. So as you can see, the hydrophobic basically had less chlorides in every single depth increment as compared to the high performance concrete. That is literally them throwing the kitchen sink of everything they could think of into this concrete to make it extra performing. And the hydrophobic still did better than all of it in regular concrete with nothing else added. Now, this study, which is one of my favorites on the left, it's a corrosion initiation study. Basically, this was done by the Virginia Transportation Research Consortium. They tested how basically it's going to look with a control, regular concrete, how long until corrosion starts, not till when the structure is completely corroded, but when corrosion starts to occur visibly. So it's a control. And then they had their high performance mix, which had calcium nitrite, silica fume, and fly ash, and then there's a hydrophobic. That's basically concrete with the hydrophobic in it. And you can see that the hydrophobic did best in the worst conditions and their best conditions. Now there's an asterisk there. You guys might ask, why is there an asterisk? Well, it's a theoretical best case scenario for 150 years, which by the way, even that is an estimate, because up until then, the average life cycle of any structure, really with all of the theoretical modeling, was about 75 years. 150 was the max case scenario because no one ever got close. It was that bar that no one could ever break up until we came to be tested. At that point, there was no signs of corrosion in their simulated model of 150 years. We literally broke the test. So there's an asterisk there because the answer is it probably could have been more than that, but they'll never know. On the right, you can see the cost savings. Talk about this before. Traffic coating is always going to cost more than what a hydrophobic is going to cost on that structure. And they're going to be replaced probably within 10 to 15 years. They're probably going to be replaced because of damage over time. And that's going to always keep on skyrocketing. Your penetrating sealers may look cheaper at first on first application. We talked about this before. They need to be applied every 4 years. So that cost is going to keep on going up and up and up and up and up. While your hydrophobic lasts, it's a one-time application. It will last lifetime of the structure, and your ownership will never have to think about reapplying ever again. So it's one less headache for them to worry about on their structure.
So this is an example of extending the life of the pilings and the slabs, literally immersed in salt water. So this is the Seattle Great Wheel. There's 5 great wheels in all the US, and this is the only one that's actually above water. So that this is over 10 years old, still looking brand new, have had no issues with it going forward. And then just on the way, we're also on the Seattle Aquarium, and then also the Seattle Aquarium expansion. So side note with that is that this will not, by using a hydrophobic admixture, will you can be used on potable water. So it will not affect the water itself. It won't leak into the water, and it doesn't affect the sea life for aquariums. We've been used on several of those.
So this is a little island on the right here, Pier 55. Originally, back in the 1920s, it was the home of White Star Cruise Lines. It was supposed to be the pier the Titanic came into shore had it made it to New York. Fell into disrepair over the years, and then Sandy hit and completely obliterated whatever structure was left. And the city, after seeing all the damage to its piers, decided that when possible, they wanted to start turning them into parks. So the idea came out in 2012, and finally they got help with the help of billionaire Barry Diller and the Diane von Furstenberg Foundation. Decided they're going to go make a nice decorative architectural park. These here, by the way, you can see at the bottom, these are flower pots. We call them tulips in the area. All the cast in place concrete for this entire structure has Hycrete in it. Including, that's all, including there's also an amphitheater. And so all of their rooms that are with all the electrical equipment all have Hycrete as the only waterproofing there. It's right, as you can tell, right in the middle of the Hudson River. So definitely a chloride rich environment. And it's kept protecting the entire area there too. In addition, we've done a lot of other work in New York City. It's one of our bigger markets. Working most recently, one of our bigger projects was Disney's making a new headquarters, and Hycrete was used in all the foundation work for that entire project in New York City. So we'll talk a little bit now about belt suspenders applications. So belt and suspenders, what is that? Basically, there are sometimes applications where you need more than one system. Think about it, things like green roofs, sensitive indoor environments. where failure could be catastrophic and there's a huge amount of liability. Basically, this is the kind of thing where you don't want owners to have occupied space. We've seen this all the time. All things have occupied space. If there's any water going in, this would be extensive damages to try to get and repair it. So in this kind of solution, sometimes it's in one system. They'll put in one system, but it's probably better to have a backup. Why? It's a two systems approach. That way, you have your membrane still there, but if that membrane breaks, and we talked about before, you have your hydrophobe backing it up. And the hydrophobic, we talked before, because you want zero chance of anything happening with the critical application and for the repair process, you're going to have a hydrophobic there with that membrane. Basically, probably one system would help, but not eliminate any need for anything. The two together, your owner will never have to worry about a single problem ever again. Usually it's been a single line defense. We all know that some of the single lines don't help. That's why belt suspenders exist, to make sure that your structure will stay dry, even in the most tough conditions. So it's going to stop that water, the dual approach, stops that water from finding its way through the membrane. It's going to not pass through, and that concrete itself. So basically, as I said before, even if there is a puncture in that membrane, your concrete's still going to stay dry. Now that protection, since it's a backup system, it's going to be cheaper than some of the warranty systems. It's going to be about 50 cents to $1.50 a square foot. Backing it up. Also, you could use a cheaper membrane when you're doing that. You don't need to use fancier systems because of the fact that it's just a belt suspenders application. It's going to be backed up by the hydrophobic. So just lets a cheaper membrane in. So here's an example where this was used in New York. It's Cornell Weill Medical College. It is 4 floors below grade in the water table, has vivarium medical equipment. Downtime would be catastrophic. You can't really have a hospital go out, and it's literally right on the water in New York. So we'd be able to minimize the liability for a small cost. They put some drainage board in, some membrane and the integral. That concrete was below 1% absorbed, and there's been no problem since, and it's right on the river. So that's really important. One of the other applications we're very proud of were used in the Freedom Tower when it got reconstructed. Now, the Port Authority itself it's really usually hesitant to use anything but their approved mix designs. They don't like putting admixtures in because they think that they know everything on the installation. However, in this area they thought was mission critical, they realized that any damage to the elevators or anything like that would be problematic to getting up and down and building that tall. So they put us all the utility rooms and below grade, anything below grade, because they want to make sure that that structure would stay dry permanently and that electronics will always be permanently protected. All right, got a question here. They're asking if our Hycrete is generic or proprietary. It is proprietary.
Great question. Yeah, and we're gonna jump through these last couple slides pretty quickly, just so if there are some more questions, because we want to be respectful of your guys' time, and your food should be delivered shortly. So appreciate that. But yeah, I mean, so we all know there's some problems in the precast. We've got the aesthetics and the durability. So you've got your spalling, efflorescence, the staining, and of course the maintenance requirements. By using hydrophobic, you can avoid all of that. So the different applications, architectural and decorative concrete, tilt-ups, barriers, and other structural precast elements. So of course, you know, some of the causes, you've got your efflorescence that are going to be wick to the surface. They're very difficult to remove, plus unsightly. Then you've got your freeze thaw, which is going to cause expansion and contraction. This is, of course, is going to jeopardize the aesthetics. And then you've got your corroding rebar, which is going to expand and crack. It's going to spall the concrete, and it's very expensive to repair. So solutions with a hydrophobic admixture like Hycrete, you're in the concrete and it does not need to be reapplied. They're not going to wear out. They're not going to wash out over time. You have reduced maintenance requirements and reduced staining, and the hydrophobic admixtures are going to enhance the durability and protect the surfaces. And another side note, if you do have a colored concrete or a polished concrete, Hycrete will not affect the color of your concrete. And it will also not affect the durability if you polish it. So it won't have any issues on the integrity of the concrete if it is polished. Just another example, we'll just pass right through this one. This is just a quick way to detail, and then also installation was a lot easier on water features, and then the mechanical room below the water features as well.
This is just a quick review. This is a project from when we first started out. It was a DOT. They put a basically Connecticut got every DOT basically took a stab in New England at different parts of research. Connecticut stuck with a visual test. This was a project that was out on the road for 9 years. You can see the control looks really beat up. The hydrophilic looks fine. It's been actually another 7 years since then. At this point, they've actually replaced the control, and the hydrophilic is still as good as new. You talk to them all the time. They drive right by it. It's on one of the most popular driving lanes between Connecticut and Massachusetts, so it gets a lot of traffic and a lot of snow. So quickly, how do we specify this? Because I'm sure that's something you guys are probably wondering. There's a few different standards we could use, 1881 or 1757 for water absorption, 1585 for capillary absorption. For erosion, we use 1556, and rebar loss 109. For humidity, we passed the DIN 1048, and basically we're standard for admixture. What's the other standard admixture? So before we let you go and answer any questions, we want to remind you guys that if you're writing your spec, you should probably, to make sure you have the best protection required, the integral concrete admixture, meet those guidelines for 212 for both hydrostatic and non-hydrostatic performance. That's crucial. So you don't basically get substituted with an inferior product. So where are you guys going to put this in? Usually the specs show up in Division 3. Now I know a lot of times architects aren't going to touch Division 3, but it's something you guys still might have some influence over. Division 7 is where you guys show up. Usually on waterproofing, you can put a note in there, definitely referring it, because it's a concrete based admixture. Usually show up in the concrete spec. Usually we have architects help write that spec language, put it into the concrete spec, and then put a note in the waterproofing specification as well to refer to the concrete specification Division 3. So,
Right, so this is our summary. Yeah. So Andrew, thank you so much. I would love to open this up if there are any further questions. Thank you for typing them into the chat. Are there any questions? Well, I will, if there isn't any just yet, I will start too. One of the questions we get asked quite frequently is, can we be used in shotcrete? And so we will warrant it if it is below grade, but not below the water table. So if that is one of your contractor's preferred method, that is something we do warrant. If it is below grade, but not below the water table. We will require a dimple board to be used in that process. But if that is one of the questions, we get that one a lot. So I want to definitely throw that one out there. Yeah, go ahead, Andrew.
One of the things I also want to remind you guys, like this is a great solution for you guys to eliminating the usage of, waterproof any below grade structures. And I know in DC area and Virginia and Maryland definitely have a lot of that. So we could basically help with that. But we're not going to make any solutions that basically don't work. We're not going to try to sell you a bill of goods. So if the solution, if it isn't basically going to save you guys money and time or provide the best protection possible, we will let you guys know immediately and won't go forward with it. We're not going to try to just push ourselves into every project possible. We want to have a good fit because we want to keep customers and we want you guys to feel secure in what you guys have. We're going to review every single, so we're going to suggest this. If you have any projects you're thinking about doing waterproofing on in general, and I'm sure you guys have a lot of projects down the line, send to us. We can basically show you how there could be cost savings using hydrophobic, and we can help work with those doing a free detailing with our architect, our engineering department doing a free detailing for you guys to exactly where it's going to go. And that's at no cost, and that's just for us to show you guys exactly how we can help. Or if you really want, we can even do an existing project and show you how much you would have saved had you used us. Either way, we're glad to take a crack at it. and we're glad to show you guys our value. We've been used in projects worldwide in thousands and thousands of projects. Worked for major companies such as Disney, Amazon, Google, Nintendo, Microsoft, just to name a few.
Yeah.
One of the leaders in this kind of technology, and we know we'll give superior performance to you guys, and we're looking forward to working with you.
Great. Well, yeah, definitely. Just, I know we're over our time, so I just want to check and see if there are any questions. Christine has my contact info and Andrew's. So we're happy if any questions come up afterwards to answer those questions for you. And we'd love an opportunity to propose on one of your projects in the future. Great. And Christine, I will work with you on getting everyone's AIA numbers and get certificates off. I saw we had a pretty good crowd on the call.
Yep, thank you.
All right, thanks. And your food should be delivered shortly. I know they were rushing it, and apologize again for that, but you should be getting it shortly.